everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion is question bank discussion on the module Partial Differential Equations. In detail, we are going to discuss about partial differential equation, how to form it, in which eliminating arbitrary constants, functions, linear equation, non-linear equation, everything in detail regarding partial differential equation we are going to discuss. The topic is question bank discussion. That is the subject, which is mathematical transform techniques, in which the fifth module is partial differential equation. The question bank system, how it is, the short answers put together 20 questions which are under part A, and question bank long answers nearly 20 questions under part B, and problem solving and critical thinking nearly 10 questions under part C. Put together partial differential equation regarding the subject, the name mathematical transform techniques, 50 questions which are divided into these three parts. These questions are selected to satisfy Bloom's taxonomy. The total 6 levels are there. The first 3 levels satisfying the question bank which is prepared. So the question bank, the system in our college, Institute of Aeronautical Engineering, the subject name, mathematical transform techniques, the subject code which is allocated AHSC07. This goes for BTech first year, that is a second sem, which is being taught. The regulation is 20. This entire course, the mathematical transform techniques, the question bank, completely 5 modules. The 5th module today we are going to discuss. The entire mathematics department put together the effort, the question bank, the questions are framed, satisfying Bloom's taxonomy. The course coordinator is Dr. S. Jagadha, myself, Associate Professor. Now, Bloom's taxonomy. So, the Bloom's taxonomy, the first level is remember. That is so for what we have learnt in lower classes regarding formulas. What is the next step to go? To go to the next step, what are the requirements we needed? So that just we will recall or recollect. So it comes under the first level, remember. So with a remember, that is a recalling, the next level we will move to understanding. So these 2 levels, with that knowledge, we will go to the 3rd level, apply. So our question bank, the questions which are prepared regarding the 5th module, partial differential equations, satisfying these 3 levels, Bloom's taxonomy, the questions are prepared. The 4th level is analyze. As the subject is being taught to first year BTech students, only up to 3rd level. Analyze a little bit more. That is beyond the subject we will be going and analyze it. Even though the critical thinking and problem solving, little bit the questions that are dominating, the questions are there, but still it comes under apply. So the 4th level is analyze. 5th level is evaluate. The last level is create. So these are all BTech third year, fourth year. So those are the levels which will be satisfied. So the format of our question bank system, our college, Institute of Aeronautical Engineering. So the module 5, partial differential equations and applications. So the part A, so here we can notice it. The second question is apply, whereas the first question, remember it is there. Because the question is define order and degree of the partial differential equations. Even the partial differential equations we studied in intermediate itself. So just we have to recollect what is the how the order and degree which are defined to PDE, that is partial differential equation. So only the recollecting part we are going to do. So which is remember that is the first level of Bloom's taxonomy. The second one is apply. So for the apply, first level, remember, second level is understand, third, the apply, completely satisfying, these questions are prepared. So now we are going to discuss the preparation of question bank, how it satisfies the three levels. What are the formulas we are going to recall for this particular problem? So recalling how far the understanding level. So with the recalling, with the understanding level, we have to do the apply to reach the solution. So the three levels, the Bloom's, how, which is connected to this particular problems. That is also we are going to discuss. So the completely the question bank, what are the questions are dominating, that we are going to discuss in detail through this video lecture. But complete problem solution we are not going to focus. So this particular problem, it is there. The complete solution, if want, then the separate videos are done under this partial differential equations. 11 videos are already released. So the 11 videos, each topic, step-by-step solutions which are given. Now, this question bank, what all we have to recall, how far our understanding level, recalling those definitions, how we are going to apply to reach the solution. These steps we are going to discuss in this video lecture. So this is the format of the question bank under this module 5, partial differential equations and applications, which is this question bank which is available in our college Institute of Aeronautical Engineering website, which is available. So now we will enter to the topic partial differential equations. So the first question itself, we have seen what is order and degree. First, an equation which involves one or two partial derivatives, which is called PDE. It must contain at least one dependent variable and two independent variables. Such equations we will be calling PDE. Now here we can notice it, dou z by dou x, which is equal to P. So the dou z by dou x, the notation we are representing as P. So the next one, dou z by dou y, that is z, which is we are going to do the differentiation partially. The symbol dou, which represents partial, we are going to do with respect to y. This notation we are noting as Q. These two are partially differentiation of first order. Whereas here the notation R which is given, that is partial differentiation of second order. So what is R? That is with respect to x 2 times the derivative with respect to x to be found. Whereas here first term x again with respect to y. So second order, we can see it the order 2 is there. So this notation is small s. So the last one is dou squared z by dou y square. So this is denoted by small t. So we have to remember this partial differential equations, the notations which they are going to play a complete role in this module, that is our PDE, P, Q, R, S and T. So the first problem, form the partial differential equation by eliminating the arbitrary constants A and B from z equal to ax plus by plus a square plus b square. So this is the question we are asked to solve it. Then first actually in our mind the given question where a and b, the two places here a is occurring and here b is occurring. Already the notations we discussed just now in the earlier slide. P, the notation is dou z by dou x. So any that among the five notations partially we can apply here, but our aim is finally the required solution, our A and B occurrence should not be there. So first, this given as we are naming as 1, we are recalling our Bloom's first level, the notation P, which is a defined dou z by dou x. So the Bloom's first level is satisfied. Now we are moving to Bloom's second level, that is, in this we are doing the differentiation with respect to x. So the x, the differentiation is 1, a into 1, a. So the p is nothing but a. So in our question, wherever a is there, now we can replace it. What we obtained, our a is p. So we are applying. First, we recalled it. That we recalling, we did the comparison, understanding level. We obtained p equal to a. Then the third level we moved it, apply. So the three levels we satisfied. The same now p equal to a, we obtained it. So now we are understanding better if we do, that is with respect to x, if we do, we obtained p equal to a. Why can't we try for with respect to y? Then there will be a possibility of eliminating this p. That idea we are getting. So with that idea, this is our given question. In the given question, with respect to y, we are partially differentiating, that is our b. So the b which is equal to, this notation is nothing but, we know it, which is q. So the q, according to our question, with respect to y, the differentiation, this is 1 into b. So q equal to b. So wherever b, if we replace q, b will be eliminated. Our question is, form PDE, eliminate arbitrary constants. Now, what we obtained, our equation 2, we obtained P equal to A. Equation 3, we obtained Q equal to P. These both we are going to substitute in our given equation that already we named it as 1. So, A which is replaced by P and B which is replaced by Q. Here A square plus B square, that is replaced by P square plus Q square, is a required partial differentiation equation after eliminating our elimination of arbitrary constants A and B. So in this particular problem, we recalled our notations P and Q. P is nothing but dou Z by dou X. Q is nothing but dou Z by dou Y, satisfying our Bloom's first level. Second level, that partial differentiation, that is also recollecting only how to do the partial differentiation. So with understanding, we did in our given question partially with respect to x and partially with respect to y. These results we applied in our given equation. After applying, we got the required solution. So what I am underlining, this is the solution, we obtained it, and we are noticing, we are observing that the constants are eliminated. In the similar manner, this is the question which is there in the question bank. The similar manner, other questions also prepared in the question bank, satisfying Bloom's 3 levels. The third level apply. Based on that, 90% of the question bank questions are prepared regarding this Model 5 partial differential equations. So the next problem which is given here, eliminate h comma k from. So this is the question which is given, x minus h the whole square plus y minus k the whole square plus z square equal to a square. So the question which is given, eliminate among the 5 notations P, Q, R, S and T. PQ for first order, R, S, T for second order. So among the 5, anything we can take it, but our aim is in the final solution, this H and K occurrence should not be there. So first we are writing the format, the given equation that we are naming it as 1. So differentiating equation 1 partially with respect to x first we are doing. So when we are doing with respect to x, we are obtaining, this is the result. So step by step it won't be there. Already I told you what are the important steps to reach. That only we are discussing in this video lecture. So when we are doing with respect to x, we obtained this is the result. So we are noticing the idea which is ringing in our mind. Now, what is the result we obtained here? X minus h is there. Okay, that which is equated to minus zp is there. So when we substitute here, h will be eliminated. So we are moving in a correct path to reach the solution. So next to the similar treatment in the same manner, first initially we did with respect to x, now we will be doing with respect to y. So when we are doing with respect to y, partially we obtained y minus k, which is equal to minus zq. So complete the thing. Yeah, better this can be removed by this. This place can be removed by this. If we do, compulsory our h and k will be eliminated. So we recalled our partial differentiation, how to do it. Understanding, we applied in our given question. The idea, correctly we applied it. The understanding level, so here our second level is completed of Bloom's. Third level, applying. This we applied in the correct particular place of our given equation to reach the solution. So the next problem in our question bank is form the partial differential equation by eliminating the constants from x minus a the whole square plus y minus b the whole square, which is equal to z square cot square alpha, where alpha is a parameter. So here they are telling eliminate constants. Whatever the among the five notations, we can do anything, but final answer A and B should not be there. First we are trying differentiating, that is this equation we will take it as 1. We will do the differentiation partially with respect to x. We have done it. This result we obtained it. That we are naming as 2. Next we are doing the differentiation with respect to y. This is the result we obtained it. From these two results only, we got the question what is there x minus a. That can be equated, that can be replaced by this. What I am underlining here, y minus b, that can be replaced by this term, zq cot square alpha. So if this work which is done, then finally that a and b which are replaced. So we recalled partial differentiation with respect to x and y, that we applied. Understanding correctly, we have done it. Finally, our aim is to eliminate constant, that we have done it. So this is the steps of following we can solve this particular problem which is occurring in our question bank. The next problem is form a partial differential equation by eliminating the arbitrary function from z equal to f of x square plus y square. So far what we have discussed is eliminating arbitrary constants. We discussed it. Mainly PQ, the notation we have taken. So immediately we obtained the result. It doesn't mean that all the problems PQ. We have to move to RST. Such type of problems also there in the question bank. Now what we are concentrating, arbitrary function. That is, here f is playing the role of function. F, which is defined in terms of variables x and y. Here we can see it, x and y are there. Seeing among the five notations, anything we can do it, but the final result, f occurrence should not be there. So the given equation we have written, First, we are differentiating with respect to x. So we are recalling the same partial differentiation. The left side, dou z by dou x. Here, f of some term, the terms which have the variables x and y. First, f part differentiation we will complete off. F for differentiation is f dash of that some term. Yeah, up to here regarding f completed. Then again, f, the function which is defined in terms of what? In terms of x square plus y square. That we have to do the differentiation partially. So we are concentrating with respect to x, the y term completely which is neglected. So x square, the differentiation is 2x. So dou z by dou x, which is equal to f dash of into 2x. So we can now see it here. So dou z by dou x, the notation is p, which is equal to f dash of x square plus y square into 2x. This we are naming as equation 2. Same similar treatment we will give with respect to y. The idea we have to see, when we are doing, this is the notation we got it. If we do with respect to y, compulsory this term will be coming. Then there is a possibility of eliminating this particular term. So the ideas are very, very important. So now, this is our question. With respect to y, partially we are doing the differentiation. We have done it here, f dash of x square plus y square into 2y. This we are naming as equation 3. Dou z by dou y, the notation is q. Now here, equation 2 is there. Here, equation 3 occurrence is there. If we do these two equations divided by, then the possibility this term will be cancelled. So we have done it here. This getting cancelled, 2 getting cancelled, p by q which is equal to x by y, and we are doing the cross multiplication and we brought it to left position. We obtained it py minus qx equal to 0. Here the function which is in our equation f, which is completely removed. So this is the equation which is in our question bank that we discussed in detail. Next, eliminate the arbitrary functions pi1 and pi2. Here two functions are there. Before, what we discussed the earlier problem, only one function is there. Now the two functions, pi1 and pi2. So this is the equation, z equal to pi1 of x plus iy plus pi2 of x minus iy. So we have to do partially with respect to x. So dou z by dou x. So the pi1, the differentiation is pi1 dash of this one. Pi1 of some term. So pi1 of differentiation. The sum term that is which is defined in terms of x and y. There x differentiation is 1. Actually here into 1 is there. Pi2, the differentiation is pi2 dash. Where, how the pi2 which is defined in terms of what? X minus iy. X differentiation is into 1. So we obtained we named it as equation 2. Now two functions are there. To eliminate that, we have to move to second order. The same, the equation 2, the first derivative of z with respect to x, once again we are going to do partially with respect to x. So when we are going to do partially with respect to x, so pi 1 dash is there. It's a first derivative. So here we can write 2 times derivative of x plus iy. Again, x differentiation is 1. That's one which is not written. Here pi 2, first derivative is there. If we do once again 2 times derivative, here x differentiation is 1. So this equation 3, that is 2 times the second derivative of z with respect to x, that equation we named it as 3. Our aim, our goal towards pi 1, pi 2, these two functions should be eliminated. Next, this is our question. This pi 1 and pi 2 to be eliminated. Now, so far, what is the treatment we have given for x? The same similar manner, we will do it for the variable y. Now, this is our question. Dou z by dou y we are doing. So, pi 1, the differentiation is pi 1 dash of the sum term. So, again, the pi 1 which is defined as x plus iy, in which y differentiation is I. That is written here. This is also pi 2. The differentiation is pi 2 dash, which is defined in terms of x minus iy. So the y differentiation is minus I, which is written here. This equation, that is, we are naming what we obtained the result 4. Again, we are going to do the differentiation with respect to y. Here, pi 1 dash is the first derivative. So it has become here second derivative, which is defined x plus iy. So the y differentiation is I, here which is written here. Already here, one I here is there. That is this I here. This we are going to do. This I as it is written. Pi 2 dash first derivative, which is written second derivative. Here I, the differentiation is minus I, which is written here. Here I into I square, the value is minus 1. Here negative sign is playing the role. This minus plus I into I square minus. So what we obtained, that we are naming as equation 5. So now we can notice it here. There's a previous slide with respect to x. 2 times we have done it. This is the result we obtained it. We named it already equation 3. Equation 3, equation 5. If we add, we can this getting cancelled, this getting cancelled. So 3 plus 5 equation if we add, dou squared z by dou x square plus dou squared z by dou y square, which is equal to 0. We eliminated 2 functions completely. So we can see it, adding equation 3 and 5. So this is the result we obtained it. So this notation is nothing but R. This notation is T. R plus T equal to 0. So this is the way we can eliminate arbitrary functions. So this is a question which is dominating in our question bank. Next, the Lagrange's linear equation. That is a linear equation, that is the degree which is 1. Dou z by dou x, the order is 1. We can see it here. This is a first order. Here the degree also 1. If the degree is 1, such PDE, we will call it as linear equation. Now specifically, which is written Lagrange's linear equation, that is, which is involving a dependent variable z and two independent variables x and y. To satisfy Lagrange's linear equation, the given equation should be in the format of PP plus QQ, which is equal to R. Here, capital P, Q, R, they are the functions of x, y, z. They are called as Lagrange's linear equation. So now, this is the question of our question bank. Px plus qy, which is equal to z. Now, Px plus qy, which is equal to z, just we are writing. We are noticing the given question, which is in the format of Pp plus Qq equal to R. This is P, then compulsory capital P equal to X. The Q is there, this is capital Q. The Z, which is occupying the position of capital R. So we have written what is capital P, what is Q, and capital R. The Lagrange's auxiliary equations are: the first step, we have to check whether the given question, which is in the satisfying Lagrange's linear equation format or not. Once the formulation which is satisfied, then we have to move to Lagrange's auxiliary equations. That is dx by capital P, which is equal to dy by capital Q, which is equal to dz by capital R. Now, this particular P, Q, R, which are going to be replaced by these values. So we are replacing in the respective places P, Q, R, what we obtained according to our question. So we obtained dx by x, which is equal to dy by y, which is equal to dz by z. So totally 3 members we obtained. So now we need the solutions, for which what we obtained the 3 members, which is easy to integrate. The any 2 members we can select. It's not strictly we have to take only the first and second. We can take first, second, or second and third, or third and first. Any among these, anything we can take. But the integration should be in a very easy manner. So this first and second member we have selected, and we are going to do the integration on both sides. So doing the integration on both sides, dx by x, we obtained log x, dy by y, which is nothing but log y, the constant to be added. Already the both are in logarithmic form, so we added log c1. Just we brought log y to the left position, log x minus log y, which is equal to log c1. This is log a minus log b. It's nothing but a log of a by b. So log of x by y, which is equal to log c1. So x by y equal to c1. So now here, what is the concept? We obtained the 3 members, Among the three members, we have taken first and second one result. We obtained it. That is the first and second, the default, we can write it u of x comma y, which is equal to constant. That's what here written. Suppose second and third member, if it is v of y comma z. These are the variables in general by default which are defined. Suppose third and first member if we are taking, we can write w of z comma x equal to constant. So instead of taking first and second in this particular problem, we can take it second and third. That is also easy integration. Otherwise, third and first also can be done. So anyway, the solution of this particular problem can be done. Now we obtained one solution. Similarly, one more solution also to be found. For that, we have taken second and third members. We are integrating on both sides. So we have got it. So this is the result we obtained it. Log y equal to log z plus log c2. Logarithmic formula we used it. Log y minus log z, which is equal to log c2. So log of log a minus log b equal to log of a by b. So log of y by z, which is equal to log c2. Y by z equal to c2. So we have taken second and third member. So by default, v of second member, here dy should be there. This is dz. So typing one, here dy, this is a dz. So y comma z, which is equal to constant. So the general, actually the solution is, already we obtained a result u of x comma y, which is equal to constant we obtained. Now we obtained v of y comma z. So put together the general solution, we can write it pi of u comma v equal to 0. So this is actually this problem, particular problem in detail we discussed it. So this is the final result, what we obtained. The solution, first one we obtained x by y, second one we obtained y by z. So the next problem, the similar manner, we can see the important steps. So we are obtaining P, Q, R, because which is in the format of linear, our Lagrange's linear equation. This is P, means the left is capital P. This is Q, the left is capital Q. And this is the final one is capital R. If the given question, what is given, which is fit to our Lagrange's linear equation, then we have moved to the next step, auxiliary equation. So these are the Lagrange's auxiliary equation. We are the particular places P, Q, R we are substituting. Before the problem, what we discussed earlier one, to solve the Lagrange's linear equation, that is should be in the format of PP plus QQ, which is equal to R. Two methods are there. The first method, the earlier problem, what we discussed, method of grouping. Now, the same Lagrange's linear equation can be solved in another method, Lagrange's multiplier. Now, here we have taken the multipliers 1, 1, 1. First, on what basis? Why we have to take specifically 1, 1, 1? Why we can't take 2, 3, 5? It's a genuine doubt. Yeah, we can see that one. First, the Lagrange's multiplier, we have taken 1, 1, 1. How to do the multiplication? This is related to x. The first member, up and down, we have to multiply. This is related to the second position. Why? Up and down we have to multiply. The third one, up and down, we are multiplying 1. That's what the same it will be coming. This is the procedure of doing these multipliers with the multiplication of the members. So we did the multiplication, we obtained it. The Lagrange's multiplier, the step is we have to, after multiplying the multipliers, the numerator to be added and the denominator to be added. If adding, we are finding this complete the denominator, the result is becoming 0. It should become 0. That is on that basis only the multiplier in this particular problem we selected this one. To get 0 on that basis this is selected. Anything can be selected. If x comma y comma z, yeah, we can select it, nothing wrong in it. But after multiplying with the members, we have to add the numerator and denominator. The denominator result should be 0. Then what we have selected, our multiplier is correct. So now the multiplier Lagrangians, the condition which is satisfied, then we can integrate the numerator. So the Lagrange's multiplier condition which is satisfied, which is written here. So we are integrating the numerator. After integrating, dx integration x, dy integration y, dz integration z, which is equal to constant. One result we obtained. So the result, default u of all the 3 members' participations are there. So x comma y comma z equal to constant. One solution we obtained. We need 2 solutions for each. Then we will move to general solution. So these are the steps we are following while solving the problems. For which the second solution purpose, we have taken the multipliers 1 by x comma 1 by y comma 1 by z. Say first member, second member, third member. Up and down we are multiplying. We can see it. The first member we multiply. Here multiplying, this x getting cancelled. Second member with 1 by y. Third member with 1 by z. After, then we will add a numerator and denominator. This result should be equal to 0. Yes, we obtained which is equal to 0. And we are integrating, we have to do the integration of the numerator. We have done it. This integration is dx by x log x. Second one integration log y. The final one is log z, which is equal to constant, which is added in the logarithmic form. Here we applied the log a plus log b plus log c, which is nothing but log of ABC. So both the log cancelled. We obtained x, y, z equal to C2. Here the solution is V of all the 3 members are participating here, x comma y comma z, which is equal to constant. So here the general solution is pi of u comma v equal to 0. So this is here Lagrange's multiplier. Taking our question bank problem, we solved it. The final one, this is the first solution. This is the second solution, what we obtained here. So one more, actually we can see the important steps of this our question bank problem. Find the general solution of we are seeing the question, immediately we are getting an idea. This is P, then this is capital P, this is Q, we have capital Q, this is capital R. Yeah, it is in the format of Lagrange's linear equation. Then we can substitute in the auxiliary equations dx by capital P capital Q, capital R. Important steps we are discussing of this problem. We are taking the multiplier x, y, z. After multiplying, this is the result we obtained. So when we are taking x, y, z, we know the condition of Lagrange's multipliers condition. If we add all the denominator, the result to be 0. On that basis only, the selection to be done. So we obtained 0. The numerator, we have to do the integration. After integrating, this is the result, x square plus y square plus z square equal to 2c, generally which is equal to c1, the first solution we obtained. So u of the first solution, default we are taking u of. All the three members participations are there, x comma y comma z, which is equal to c1 constant. One solution we obtained, one more which is required for this problem. For that, we have selected L, M, N. So similar manner we are doing what we have done. This is the result we obtained it. So solution is V of x, y, z equal to C2. General solution is both combining. We have written pi of u, v equal to 0. So here we want the complete solution of this problem. Lagrangians linear equation multipliers, separate video which is done, in which complete solution which is available. So the final one is pi of x square plus y square plus z square, comma lx plus my plus n z equal to 0. So now, so far we concentrated the linear equations under Lagrangians, their method of grouping and multipliers, we discussed it. Now, non-linear, if they are, how to solve the non-linear equations we can see, for which 6 standard forms are there along with Charpit's method. These 7 using especially non-linear equations we can solve it, for which the standard form 1, among the 6 standard forms, how they are differ from among themselves each other. The first form, if it is only has P and Q, then it comes under standard form 1. Whereas here we can see that what which is denoted here, the sentence, the equations containing only P and Q. Then the solution, this is the formula related. If the given problem falls under, if it has only P and Q, then this is a solution of that particular equation. So now dou z by dou x, for which here P. In this, the notation we know it, dou z by dou x, it's nothing but P. According to this equation 1, P equal to A. Dou z by dou y, the notation we know it, Q. If we do dou z by dou y, Q equal to B. This P and Q, we will, whatever the question we are asked to solve, P and Q will be, values will be replaced. That is, P place we will put it A, Q place we will put it B. And after substituting, we will obtain to the value of B. That value we will put it here. So this is the step of the formulation of standard form 1. While solving the problem, these to be followed. Just a question bank problem, which is that how to solve it, we can discuss now. Now, looking at this question, P, Q are there. So only it has P and Q. M is treated as constant. Now we are playing, we are discussing with X, Y, Z, P, Q. These variables we are discussing. Among the 5, if it has only P and Q, it comes under standard form 1. For which the general solution for the standard form 1, this is formula related. So we will, what is P? We know it. Just we discuss P equal to A, Q equal to B. That we will substitute in our question. After substituting, from which we will get the value of B. Then finally, in our equation, B to be replaced it. So this is the way we are solving this problem. First, we are checking whether the question standard form 1 or not, understanding Bloom's second level. Just recollecting the steps of standard form 1, that is level 1, remembering. Completely we are remembering what are the steps formula related to a standard form 1, and these are the steps we are applying in our question. So Bloom's 3 levels full complete question bank which is satisfied. So next actually we are noticing this problem here. P, Q, Z, it is there. X, Y, the two variables are missing. It comes under standard form 2. So the given equation is P square plus PQ, which is equal to Z square. This we are naming as equation 1. Here PQZ is there. Z equal to F of U. U we are assuming as X plus AY. The solution of the given equation, the formula related. This is the step of standard form 2. Given equation where it is mentioned that is related to the question which we have to solve. In the given equation, wherever the P is there, that to be replaced by dz by du, Q which is replaced by A into dz by du. So this is our given question. We are replacing P by dz by du, the square already which is occurring in the equation, square, and P is dz by du, and Q is there, that is replaced, which is equal to z square. We are finding dz by du the whole square which is common. We have taken it outside. Here the leftover is 1, here the leftover is A. Just dz by du the whole square which is equal to z square by 1 plus A. So dz by du we are finding what is that? Then we are separating the variables related to z one side and u another side, and we have to do the integration on both sides and we will obtain to the result. Suppose the question if it falls on standard form 3, it has only p, q, x, y variables, z is missing. Then xp and all will be grouped to one side, yq the terms will be grouped, both to be equated to the value a. Then we will solve p and q. Finally, after getting the value of p and q, we will substitute here. So if define the steps of standard form 3, this is to be done. So now we can see it here looking at this is our question bank question. P, Q, X, Y, Z is missing. So it gives an idea that better we can select standard form 3. We selected and P, X and all to be grouped. We grouped it. It should be equated to the value A. These are the steps of standard form 3. And Y, Q, they are grouped, which should be equated to A. We have to, from this, we have to obtain the value of P and Q. That is the next step. After obtaining, here we can see it, P minus X square equal to A, from which obtain what is P. And from this, we obtained what is Q. After getting P and Q, This is the formula, it should be substituted. Here also integration to be done. So z equal to p dx plus q dy, and both the sides we have to do the integration. So important steps are discussed to reach the how to solve this problem. Suppose the question it comes under standard form 4 problems. All the 5 variables will be there. The given question we have to rewrite, that is px, qy, pq format. Finally, p should be replaced by a, q should be replaced by b. Here we can notice it, this is the question which is given. It is not at all in the standard form 1. Standard form 1, only PQ. No, here XY also is there. All 5 are there. So we can. But the question should be, we have to rewrite in such a format which is defined for standard form 4. So we are rewriting in such a way. Some simplifications we have to do it. After doing this, we obtained it. And wherever P, we have to replace it by A and Q by B to get the required result. This is the solution for the given problem what we are discussing. Next, so far we discussed the problems. Up to there, X and Y, they are not at all having the powers. But in this particular problem, which is in our question bank, X and Y, they have the power. And the power also 2, it is there. When we are bringing P up, x square, P power minus 1. This is the way, the first term. But the standard form 5, it has a format that is x power mp and y power nq. This is the format, the function to be defined. So for that, p power should be 1, but we are finding p power is minus 1. So we have to modify to get the standard form 5, the equation is changed. So the equation is formatted. Next, so the standard form 5, according to that, here m is playing the role minus 2. If 2 conditions are there, that is, case 1, if m and n equal to 1, our assumption will be different. If they are not equal to 1, now our case is m and n minus 2. That is, they are not equal to 1. So capital X we have to assume in such a way. Capital Y to be assumed in such a way, that is capital Y, which is equal to y power n 1 minus n. This notation already we know it. Then what we assumed our capital X to be inserted here. So we can see it here, dou z by dou x, dou z by dou capital X, dou capital X by dou x. Our insert, what we have done it is correct. One is up, one is down. We can cross check it. So now we are doing this P. The small p, the notation is dou z by dou x, both z and x lower cases. But anyone which is in capital P notation, this is not related to any mathematical method teaching, just to remember some technique, that's it. Now this capital X with respect to small x we have to do it. Before that, here capital X equal to x power 1 minus our m is minus 2. X power 3 we obtained it. This we have to do differentiation 3x square. So we are obtaining p by x square equal to 3p. So the idea we have to see, this p by x square we can write p x power minus 2. Our question, what we modified it. So better in this particular place, the 3p can be replaced. Same treatment if we give for y, we will obtain capital P. This is q by y square equal to 3. Capital Q we will obtain. So this is q y power minus 2 equal to 3q. That will be replaced here. So we can see it. After replacing, this is the equation we are obtaining. And we are noticing after all these changes, here P, Q, Z, the three are there, X, Y completely eliminated. But ours is, we are proceeding the steps of standard form 5. After applying that, the equation, the standard form 5, which is reduced to standard form 2. So from now, we have to obtain the steps of standard form 2. So these all applying our Bloom's taxonomy third level, which is satisfied. So these are the steps of our standard form 2. So we can see it, P, Q assumptions that we have to substitute in our given question. After substituting, and we have to do the integration, the final u which we replaced this term. So from here we obtained standard form 2 steps. So the next problem which is in our question bank, z square. The previous problem, x and y, they have the power, but here z is having the power. When z, which has the power, that problem comes under standard form 6. So now standard form 6 of the format is PQ, they should have the power 1, z will be having the power n. Here which is equal to that n minus 1, one assumption. If it is not equal to minus 1, another assumption. Now ours is here, z is having the power 1. That means which is not equal to minus 1 condition. So our z we will be taking z, capital Z equal to z power n plus 1. Here we can notice that n is 1. So we will substitute here capital Z equal to z square. So now we will do the capital Z equal to z square, we obtained it. That we will do partially with respect to x. So now dou z by dou x. This is z square, that is 2z, dou z by dou x. So the capital P equal to 2zp. Capital P by 2 equal to zp. The same treatment we will give for y. If we give q by 2 equal to zq, that we will substitute in our given equation 1. This will be replaced by this, zq replaced by this q by 2. Now we are noticing our standard form 6, which is reduced to the equation which has pqxy. It is nothing but standard form 3. From now, what are the steps to be followed for standard form 3 we have to follow? So standard form 3, the rules are px to be grouped and equated to a. But here the position square is there, so a square. Same qy should be grouped, they should be equated to a. In our particular problem, squares are there, a square. This is the standard form 3, the steps. Solve p and q. After p value we obtained, q value we obtained. After obtaining, here also integrate capital Z equal to p dx plus q dy. Then we have to do the integration, constant to be added to get the required solution for standard form 6. So here important steps of this problem we discussed in this video lecture. All the problems, what are the important steps? 60% of the each problem we discussed, because we have to discuss, as it is a question bank discussion, more problems to be covered, but complete solutions which are available in separate videos. Now, this problem, if you are taking px plus qy equal to pq, it is a non-linear equation. All the 5 variables are there. P is there, q, x, y, and z also is there. In this particular question, z is not there, but f, it is a function which is defined. Here, specifically, we are going to take Charpit's method discussion to substitute in the Charpit auxiliary equation. What are the terms are required? First, we are finding. First, dou f by dou p. We are searching in our given equation where p is there. 2 places p are there. And we are doing the partial differentiation. We obtained x minus q. In the similar manner, dou f by dou q we are finding. Here is there, here is there. Then y minus p. Dou f by dou z, there is no z variable at all, so which is equal to 0. Next, dou f by dou x, what I am circling in the first term, x is there. So x, which has 1 into p, p. Dou f by dou y, here y is 1 into q, q. So all the terms we made it ready to substitute in our Charpit's auxiliary equations. So this is the result we obtained. So this is the Charpit's auxiliary equation, that is dx by minus dou f by dou p. This we are going to replace it by this value x minus q, dy by minus dou f by dou q. So it is replaced by y minus p. Similar manner, this is totally 5 members are there. Even the third member, fourth member, fifth member, all the 5 members, what are the terms are there? We will pick from this table and we will substitute. So after substituting, so the substitution is over. The last 2 members we are noticing. Now our aim is, we want what is p and q. So to obtain the value of p and q, 5 members are there. Among the 5 members, any 2 members we can take, which is easy to do integration. So on that basis, we are seeing the last 2 terms which are very easy to do integration. So we are doing the integration, we obtained, this is the result. So now the simplified format we put it. Now the equation 1 and 2, we will solve what is p and q. This is our given question. This what we obtained it here. So in the given question, where p is there, that is replaced by qc1. Here also p is there, it is replaced it. So we are doing the simplifications where it is possible. We obtained q. So again, this is our given equation. We want the value of p in terms of x and y. So we are substituting q value, what we obtained it here, that we are replacing, and p we obtained it. So here also we discussed very, very important steps we are obtained. So the given equation, the auxiliary Charpit's formula we recollected, just we put it. Partial differentiation we are using. We found the term values, we substituted. Our aim is to find the value of p and q. So here also one more problem, the same similar manner. This is the equation, we put it in one side, left position. The equation, all the terms which are required in the chart bit, dou f by dou p. We want it. Here we are saying p is 1. We are taking this position. That's what here minus is dominating. Same q, here 1 minus p xy, 2z, x is 1. So pqy, y is 1, pqx. The term is coming left position. That is, we are writing z square minus pqxy, which is equal to 0. Everything we are going to substitute in the chart theta auxiliary equation. Substitution is over, and whatever the any member we can take it, or any simplifications or any multiplications up and down doing, and we have to get what is p and the value of q, and we will reach the final solution. So another question bank problem. This is the problem pxy plus pq plus qy, which is equal to yz. Auxiliary equations are there. The same similar manner, we will find all the term values, the particular places, substituting, we will reach. First, we will find among the 5 members, any 2 members which is easy to integrate, we will select, we will obtain the result of P and Q. So here we can see this is the result we substituted. We are taking the 4th term. It's very simple one. dp by 0, which is very easy to do integration, p equal to a. So we obtained what is p. Same like that, among the 5 numbers, any one member or comparing with 2 members, which is easy to integrate, we have to search. That is our first, the target to be done. Then we will substitute in our given equation, where is p, we obtained the q value. After getting p and q, we will dz equal to p dx plus q dy. We have to do it. We have to do the integration. After getting the integration, what is the solution? That is the required one. So now we will come to a conclusion of this topic, question bank discussion for the module 5 partial differential equations. What is partial differential equations first? Which will have the equation partial derivatives, one dependent, two independent variables, order, degree, and to form the partial differential equations, eliminating arbitrary constants, functions, and the linear, especially Lagrange's linear equation that we discussed, which should be in the format of pp plus qq, which is equal to r. There the two methods, method of grouping and multipliers. When we are coming to multipliers, they are selected on the basis of the condition, the concept of when we are adding the numerator and denominator, the denominator value should be equal to 0, then we will integrate the numerator. Then finally the non-linear 6 standard forms plus chart bit. Standard form 1, PQ dominating. Standard form 2, PQZ, compulsory XY should not be there. Standard form 3, PQXY. Standard form 4, all are there. Standard form 5, X and Y will be having the power. The power which is equal to 1, not equal to 1. 2 cases are there. Standard form 6, Z is having the power. Here, the power which is equal to -1, not equal to -1. So all the 6 standard forms, but standard form 5, which will be reduced to standard form 2. Standard form 6, which is reduced to standard form 3. And Char-Pitts method, the auxiliary equation, the 5 members are there, for which what are the partial differentiations are required in advanced doing in the respective places we will substitute. So among the 5 members, any members, a single or comparing with 2, we will obtain the value of P and Q Then we will substitute dz equal to p dx plus q dy, which is the required solution. So in detail, we discussed about partial differential equations. But so many problems we discussed, important steps we discussed, but all those problems complete a solution. Really 11 videos which are available for partial differential equations. Their complete solution step by step with animation, which is already done, which is available in the YouTube channel. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.